Reshma? Reshma ma'am? Reshma ma'am? Hello, Reshma ma'am?
Sir, yes, sir.
Ma'am, I'm changing host to you, ma'am.
Yes, sir, I have. Yes, sir, I just, okay, sir.
Yes, ma'am. Now just check out, go to the participant list, ma'am.
Yes, sir. Make host, co-host, it's coming, sir. Yes, sir.
Okay, you can do it. I will start up the live
stream. Okay, sir. Sure, sir. Thank you, sir. Okay, sir. Thank you, sir.
Ma'am, share the poster, ma'am.
Yeah, sure, sir. Now I'm sharing, sir. Sir, is it visible now, sir? Aarti, ma'am? Gautam, could you please unmute? Yeah, thank you.
சொல்லிட்டோம்னா அடுத்து அது ஃபில் பண்ண அதுக்கு மெசேஜ் போட்டே இருப்பாரு. सबसे नीक मास्टरी का नौकरी ना। अब आओ फिर तू में खाना वाना दे देते तू। अच्छा
Sunish sir, good evening, sir.
Yeah, hello, good evening.
Yeah, thank you, sir. Sir, we will start soon, sir. We'll start in a minute. Yes, sir. Yes, sir.
Yeah. I hope you can see my video, right?
Yeah, yes, sir. Yes, sir.
Yeah.
மைக் ஆனீங்களா?
Sunish sir, shall we start, sir?
Yeah, sure, we can start. Yeah.
Yeah, sure, sir. Sure, sir.
Yeah.
ఏంది ఈ పక్కన మైక్ సింబల్ పడదు ఇక్కడ నీది మైక్ సింబల్ పర్లేదు.
Nitin, could you please mute your mic? Thank you. Thank you.
Yes, ma'am. Sorry.
Yeah, it's okay. Fine. Thank you. So, a great evening to all present here. Education is the most powerful weapon which you can use to change the world. It's all about creating an environment of academic freedom where the bright minds will learn. I, Reshma, Assistant Professor from the Department of Electronics and Communication, SRM Institute of Science and Technology, Ramapuram campus. I take immense pleasure to welcome all our resource person, Dr. Sunish Kumar, and our participants to the webinar series Futuretronics 2021, conducted by the Department of Electronics and Communication Engineering, SRM Institute of Science and Technology, Ramapuram campus. SRM Institute of Science and Technology is one of the top ranking universities in India with 20,000 students and 1,500 faculties offering wide range of undergraduate, postgraduate and doctoral programs in engineering, management, medicine, health sciences and science and humanities. The flexible and the dynamic curriculum, exciting, the research and global connections are the features which makes our campus in heights. The students having a wide range of cutting-edge programs like nanotechnology, bioinformatics, genetic engineering, remote sensing, and embedded systems to choose from. The crux of this webinar series would help all the students to expand their knowledge across wide dimensions in engineering. I request all participants to make the use of this webinar to their best abilities. Our resource person, Dr. Sunish Kumar sir, has completed BTech degree in Electronics and Communication Engineering from Cochin University of Science and Technology, India in 2005. And he has completed MBA degree in Human Resource Management and Finance from Kerala University by the year of 2010. Dr. Sunish Kumar has completed MTech degree in Optoelectronics and Communication Systems from Cochin University of Science and Technology in 2013. and a PhD degree in electrical and computer engineering with specialization in optical communications and engineering from Memorial University, Canada. Dr. Sunil sir was working as postdoctoral researcher at the University of British Columbia, Canada. And sir has experience in various universities across the world. And currently, sir is working as assistant professor in electronics and software engineering in Ulster University, Northern Ireland, UK. So I welcome sir to, and I request sir to take over the session, sir. Sir, I'll make you as yeah, sir, I'll make you as host, co-host. Yes, sir.
Yeah. Thank you so much, Reshma, for the nice introduction. And
Yeah,
I would like to welcome all of you to this session on the brief introduction to principles of communication systems. And I thank Dr. Fani Kumar, the convener for this webinar, and the coordinators Reshma and Aditi for organizing this nice event. And once again, thank you so much, Reshma, for giving me another chance to to present some of the research topics and share with the students.
yeah, it's our great,
Guys,
great pleasure. Thank you so much.
Yeah. Thank you so much. So
Yeah,
good evening,
yes.
all. Yeah. So I hope our target audience are basically plus two. I mean, higher secondary and diploma students. I hope, right? Anyway, I mean, my talk is somewhat covering on some of the basics of the communication technology, communication systems. So it's not like a fully technical talk. It's some introductory talk on some of the basics, and we will touch and we will just go in some of the keywords that is the current research areas. I think some of your microphones are on still. If it would be great if you can mute the microphones. So and we will give you a chance to ask questions during the or after the presentation. Yeah. Hi Reshma, can you please insist? I mean, some of the students' microphones are still on. Yeah, I mean, I am seeing some kind of a background noise, so it will be
Yes, sir. Sorry,
great.
sir.
Yeah, no problem. I mean, it happened. It's it's a webinar,
Participants, could you please make your mic mute? Could you please make your mic mute, participants?
Yeah.
So
Anyway,
now it's
so
fine.
yeah,
Okay.
I think so. Yeah. Okay. So I will share my screen. I think you are able to see my presentation, right?
Yes, sir. Yes, sir. It's visible. Yes.
Okay. Okay. Anyway, so we have seen right now, some noises and some disturbances which will affect the talk or presentation. That's the best example of interference in communication system. So anyway, we will going to touch these kind of stuffs in the presentation. And I mean, this is the best example of how a communication is affected by the noise, the background noise. Anyway, I'm just feeling sorry. So again, welcome everyone to this brief introduction to the principles of communication system. As part of this Future Chronics webinar series, I'm very delighted.
క్లాసులు వేరే క్లాసులు ఎందుకురా నీకు నేను చెప్తాను అనుకున్నా భయపడుతున్నా చెప్పాను
Students, kindly please make your mic mute. Ankit, please make your mic mute.
Yes, ma'am.
Yeah, thank you, please.
Okay, great. So what I'm planning to talk in this presentation is we initially talk about what is communication, what is basically the meaning of the communication, or what is the necessity of communication. And we will cover some brief history of the communication technology. And we move on to some of the technical aspects of the communication system. We talk about a general block diagram showing what is communication and what are the different processes or steps or techniques involved for a reliable communication through a channel. Then we will move on to a little bit on wireless communication systems. What are the principles behind that, and what are the existing technologies, and what are the future technologies leading to, for example, the so-called 6G, sixth generation of communication systems. And towards the 6G, what are the technologies people envisioned for the deployment of the 6G wireless communication systems? So these, I would like to just coin few of the words on technologies or the techniques or the systems or subsystems that has been, researches are going on to include those in the 6G communication system. So we will not go into the details of the technologies, but I will just point out some of the keywords that will help you, some of you, to understand what is going on in this communication technology and what is 5G, 6G, and what are the major differences. So generally, what is communication? So everyone, this is a very simple question, but very difficult to answer. So generally, what is communication means we as human being, we cannot live without any communication. So at any point of time, we are doing some form of communication between our friends or between, any other means like emailing, chatting, Facebook, WhatsApp. All these are the different forms of communication, and all these communication technologies are built upon certain necessities, because as a human being we need to communicate, we need to share our information, we need to show our emotions. So all these comes under the single word communication. So okay, let's see a general communication scenario where two people talk in a restaurant. So before going to that, I will just point out some single sentence on what is communication. So in general sense, communication is the process of sending and receiving messages through verbal or non-verbal means. So this communication is, in general sense, a message transfer between two human beings. Okay, let's think about you are in a restaurant and you are talking to your girlfriend or boyfriend on either way, and you are having a nice chat between you guys. So you order some food, and on the table some food are there. So your girlfriend is talking to you. Okay, this food smells very delicious, and okay, you as a response and acknowledgement, you say, okay, thank you, thanks. And in the backside, you are thinking, okay, why she say like that? I mean, she wants to try a bite or something like that. I mean, these are the thoughts going on inside us, and we also responding. So this is the best example of a very complex communication system. If you simulate or convert this to or emulate into a technical aspect, this is a very, very complex communication. But in simple words, we are transferring messages reliably. So in this case, the guy here is a receiver. You can say a receiver who hear the what the girl is talking. I mean, at the same time, he's responding. So any entity can be both transmitter and receiver at the same time. So that is what is called the bidirectional or full duplex communication. So you communicate here, respond back on all these things. So, I mean, before moving to the technical side of the communication system, I would just wanted to, point out some of the technical stuff, hidden here in this general person-to-person communication. So, see what is about she's talking about. She's talking about something, some message, that's a food. Okay, so that is something you need to talk about, and you have to say, okay, this is a delicious food. That is a message she encodes or understands from what she has seen on the table. And she says, okay, it's a delicious food, and that message passes through air. That air is the channel or the medium, you know. So, and in this communication, both of them can see together and also hear. So it can deliver a lot of information all together. Assume that there is something in between these two persons, like there is some kind of separation, then only the sound can travel. So, you know, this now in this channel, there is no such obstacles. So, and there is no other people sitting around. For example, there are many people sitting around and talking. There will be a lot of talkings. It will be a lot of noise. Even the boy cannot hear what that girl is saying. So that is what is called the interferences and noises that is interfering with your message. So, you know, and also the boy is thinking, okay, does she wants to try a bite something? He is kind of in a doubt, you know. So that is the intelligence he working out. So applying the intelligence to the communication system, it makes the communication more, you know, more beautiful, you know. So that intelligence, what I mean is artificial intelligence in the technical sense. Something like you may have heard about the machine learning techniques, artificial intelligence. Applying this artificial intelligence also gives you a more effective communication between the sender and the receiver.
हाँ अभी
Okay.
चलो पानी पूरी खाने मेरे को लेट हो रहा है फिर
Yeah. So that is what is a general communication system.
पानी पूरी खाने चलो ना
Sir, really sorry, sir. Rahul,
It's okay.
Rahul, could you please make your mic mute?
Reshma ma'am, you can mute everyone, ma'am. You have the control.
मोमो भी खाना है मेरे को पानी
Yes,
पूरी
one
खानी है पहले
You can mute everyone, ma'am.
Yeah,
Reshma,
yes,
ma'am.
yes, ma'am. I'm checking, ma'am.
भाई सेक्स कर दूंगा पता भी नहीं चलेगा
Sir, please proceed, sir. I'll do it. Sir,
Okay.
please proceed.
Yeah,
sir.
so no problem. Yeah, I think you have the option to, you know,
Yeah, yes, sir.
mute
Yes, sir.
everyone.
I'm checking,
Maybe.
checking,
Yeah,
sir.
that's okay. That's fine. I mean, yeah, that's fine. Anyway, so technically speaking, what is communication? I mean, let's see what Wikipedia wants to tell us about what is communication system. So a communication system is a collection of individual
Sir, could you please unmute, sir, once?
Hello, Reshma. I think
Yes.
muted me
Sir.
too. That's right.
Yeah, yes, sir.
Yeah.
Yes, sir. I have muted everyone. So now it's audible, sir.
Okay,
Your
okay.
voice is audible.
Yeah,
Sorry,
yeah,
sir.
yeah.
Sir, really
Okay.
sorry for
No.
the interference.
Yeah, no problem. No.
Yeah.
No problem. These are all are the examples of interferences and noises in communication. You know, this is what we are going to talk anyway.
Yeah.
So
Yeah, fine, sir.
how
Thank
much? Yeah. Anyway, so okay, when you search Wikipedia gives me a nice introduction. I mean, nice statement on what is a communication system. So it's basically a system which is a collection of individual telecommunication networks. I mean, it's a collection of many entities together, and a transmission system. You know, relay stations. That is what somewhat in between the transmitter and receiver. We need to, you know, boost up your signal for a further reach of your messages. Tributary stations and terminal equipments. So it's generally a collection, a connection, or interconnection, or interoperation of several systems or entities together, or systems or subsystems. So it's a complex network. It's consisting of the interconnection of all these components. So the ultimate aim of all these connections, interconnection systems, subsystems are to deliver a reliable message transfer. As we have seen in the previous figure, here the sender is that lady or the girl, sorry, and the receiver is that boy. So the ultimate aim of any communication system is to deliver information reliably. That's very important. Reliably without much latency. What do you mean by latency? It's without much delay. If someone is talking to you, you should respond immediately. So everything you can connect with our real life communication systems. Even the technologies are all adapted from the real life, real life scenarios or real life activities what we do when you communicate with someone. So the second sentence it says about the components of a system, communication system serves a common purpose. That means the common purpose means the ultimate aim. The ultimate aim is to reliably transfer the information, and all this network should be technically compatible, and then only you can efficiently or effectively connect all these subsystems for the reliable transfer of communication. So I'm not going much details or much technical talk. I know our audience are basically students who are aiming to go to the university to acquire a degree either in communications or any other field. So here I just want to introduce some of the very basics of communication, why this technology is being very developed now, and what is the need for this communication, and what are the current state of the art leading to a higher generations of mobile communication. So let's see about some few history of the technology, communication. As I told, from the beginning of the mankind itself, people do some form of communication to transfer some information. For example, if there is a natural calamity or something unusual happening occurring in the historical time, people use smoke signals. They generate fire and make smoke to. That is kind of a visual communication. The people from the far, they can. It's kind of an indication that something is going on. So that's a form of communication. That visual, that it can be categorized under the visual communication anyway. So we generate a smoke signal. That's a form of communication, intimating about something. So when time flies, it go to something like people communicate over long distances. So the smoke signals, it can be viewed from only short distance. So you have the problem of the reach. So people go to some other form of communication. People use pigeon as a carrier. You tie your return message in the legs of the pigeon, and it will fly over to the other place, and it will deliver the message like what the postmen are doing right now. So when it comes to the technological advancements, people try to use some kind of coded languages or called a Morse code. Then comes to the wireless radio. People uses the radio frequency signals to encode their message and transmit. So it has much higher reach than the previous stages of communications, than the telephone network, fax machine, mobile, the cell phone, then the internet, and the interconnection of everything, email conversations, and the handheld devices or wearables. So what is next? We don't know what will be coming into the next. So when we look into this arrow flow, you can see that from one method of communication to the next generation of communication, what is the difference? A difference is reach. It will increase the transmission distance. It can able to deliver your message to a longer distance, more reliably, and the latency, the pigeon can fly, in some speed compared to the visual information what that smoke signals can deliver to the receiver. So the reach, another typical word is a capacity. That means the amount of information you can encode in your signal. Like telephone, many uses can be included. The fax machine is delivering the huge amount of data. So in every stages of communication flow, you can see that for each step, advancing is amount of reach, amount of capacity, that is amount of information you can transmit, the reliability, that's another important thing. So all these are the, nice flow of communication from the historical time to the current scenario. So still we don't know what will be the next, it's going on, it's still going on. The area of research in communications are still going on. So then, okay, just go to some of the technical principles of communication. As we see in any communication system, there will be a sender we call transmitter. In this case, this particular girl is a transmitter who is sending the information, and there will be a receiver. So the ultimate aim is to, transmit the signal or the message from the transmitter and receive in the receiver side with reliability or reproducibility. So see what are the different complex steps involved or different blocks involved in this communication. Communication from the transmitter to receiver, the flow from transmitter to receiver. So let's see. I will just point out all these blocks. It has its own functionality, its own techniques, its own methods to do all these processes. But I will just point out what is in a very the big picture. I'm not going in detail. Anyway, let's see. So here in this figure, a girl is talking over the phone, and the guy on the other side is hearing that what she is talking. So here the message what we generate is kind of in analog form. Let's see something like a waveform. This one. So the problem is we cannot transmit as such to it through the channel because we have channel here. It can be any kind of medium. It can be a wireless medium. It can be a wired medium, either a coaxial cable or a fiber, whatever it is. We cannot transmit as such the same information. So we need to convert that into some another suitable form, which a channel is able to, handle the signal that you are transmitting. So that is what is called the analog to digital conversion. So whatever we speak, we generate analog waveform. There is kinds of sinusoidal waveform. We convert that into a digital form. Then this same signal can be represented in terms of some of the digits. So it will be easy for you to process at the transmitter as well as at the receiver. Then we do some kind of encoding. Encoding is to reduce redundancy. I mean, unwanted informations be kind of removed from the whole information, and we transmit only the usable information. And then we do some kind of process called a modulation, because as I said, the signal cannot propagate long distance if it is in the bare form. So what we do is we modulate, we take another carrier, something like in the case of pigeon, you have seen here, this pigeon is the carrier, because for example, you have a return message in a paper. If you throw that paper, it cannot go, or only it can, reach to a very shorter distance. So once you tie that, the message in the legs of pigeon, when pigeon fly, it can go to the longer distance. So that is what is the idea of carrier. You need a perfect carrier to carry your message. So in technical means, we do some kind of process called a modulation. So we modulate a particular carrier, we modulate a pigeon with our message and send through the channel. Then we do some other kind of techniques called multiplexing. So I mean, if you need to, if you have many messages or many users using the channel, you need to transmit a huge amount of information, right? If there's only one transmitter and one receiver, or one person talking to one person, it will be easy. Like, okay, you no need to multiplex. You can just go through the basic blocks, encode, modulate, and transmit. But the problem comes if there are multiple people using the channel, sharing the channel, and you need to accommodate all these, transmitter receiver combinations within the available resource. What I mean is channel resource. So you should do some kind of techniques called multiplexing. So multiplexing is a technique. It will share many user data or information. It will share the same channel. So we will see what are the basics, what are the different multiplexing techniques available in the current state of the communication system. Then again, multiple access. So, if you talk about the capacity, I mean, you need to, accommodate many user data, and you need to reliably transmit it and with less error. So you need to utilize some kind of other techniques in the channel itself. So this is called a multiple access. So when you see the blocks on the left side and right side, both are kind of a very complementary. Like in the analog to digital conversion, there will be digital to analog conversion at the end. Then encoding, correspondingly decoding at the receiver, modulation, demodulation, multiplexing, demultiplexing, multiplexes, again multiplexes. So this is what the interesting time, the multiple access. We will talk a little bit more about the multiple access when we, when we go to the, that session of the presentation. Anyway, I'm not going to talk very detail about all this. So just wanted to coin all these words towards you. Some of the words will be on your head and it will help you in the future. Okay, if some of you may go to the communication systems for your undergrad study, okay, you heard, oh, this is something that particular guy talk about, this encoding, modulation, all this. So just keep in mind all these keywords. We are not going in deep into the details of each and every block, but I will show you a little bit of information on how we do all this effectively. So let's talk about what is analog to digital conversion. Okay, just see, very simple. Whatever the message information we generate, in reality, in real case, it is an analog waveform. So what I am talking right now, if I'm talking through a microphone, yes, of course I have a microphone on my laptop. So that microphone converts what I'm talking, that analog signal, and that's called a transducer. It converts that my sound pressure wave into a corresponding electrical waveform. So that electrical waveform somewhat looks like this curve, this first figure on the top. So this is a sinusoidal waveform. So as I said, we cannot, you see, I'm talking from here, from UK, from Belfast, and people, you are sitting in Chennai and maybe some part of the world, I don't know. You are hearing, you are receiving all this information effectively without much delay, how it is happening. So that is these are the different blocks comes under. First thing is analog to digital conversion. We have to convert our actual analog generated data to a digital form. So what is the meaning of a digital waveform? Many people, even if I asked a graduate from engineering, electronics and communications engineering, they also may not be clearly say, okay, people will say that this is digits, okay, ones and zeros, that is digital or analog to digital waveform. It's not like that exactly. So what is happening here is we cannot transmit all these waveforms, we cannot dump that complete signal information to the channel. We do some kind of sampling, I mean, we don't need to transmit everything. So what I wanted to do is I just want to sample this analog waveform in 2 dimensions. One is the time and amplitude dimensions. I mean, I will transmit only a discrete time samples and the discrete amplitude. This is what the second figure shows. There's a conversion from analog to digital waveform. Then, you can do opposite operation at the receiver side, that is called a digital to analog conversion. Once you receive this kind of a waveform, if you design a particular network which is able to recover the envelope of this digital staircase waveform, what you see, it is exactly what is be transmitted. This is the analog waveform. So in this form, you can convert your analog signal to a digital one and digital to analog. So that is analog.
Do Marlboro Advance or do light.
Yes, someone is talking along with me. Thank you for that. Who is that? Anyway, so let's move on to what is the next encoding. So after analog to digital conversion, we do some kind of encoding and decoding, encoding at the transmitter and the decoding. So this is a combined figure showing analog to digital conversion and some kind of encoding. So as we have seen in the previous slide, we have analog waveform. We sample it in time and amplitude. That means we have discrete time samples. We see these lines shows the discrete time samples and the discrete amplitudes. That what
Marlboro.
So once we have this staircase quantized waveform, what we do is we encode that into a corresponding bit domain.
Sir, sir, really sorry. Again, some have
Yeah.
joined, and again I have muted
Yeah,
them.
yeah, yeah.
So again, now it's fine, sir. I can hear
Yeah.
your voice. Yeah, thank you.
Okay. Yeah, I'm very happy because we are talking about the communication and we'll be talking about the interferences. So anyway, I am hearing a lot of interferences in some point of time. So that is what is the this is how the communication system is affected. So we need to clear out these interferences with different technologies. That is what is the ultimate aim of any of the communication system. So anyway, I'm happy. Like this is kind of a nice demonstration on how a communication system will be affected by the intruder or the noise. Anyway, I mean, let's move on. So we convert into digital form. The digital forms are actually a digit-wise representation of your analog waveform. For example, my speech. So it can be easily converted to a bit domain. So once you have the bit domain, we use different, pulse encoding to, for the transmission. So at the receiver, what we do is just opposite of this. We do the digital to analog conversion to recover our signal. So it is very simple to see block diagram. It's simple to see the the flow of the block diagram, but this whole process involves a lot of coordination between the different systems and components and several sophisticated designs to to avoid any loss of messages. So then, okay, so what we have, we just talked about analog to digital conversion and the encoding of your digitized information into bit form.
अरे भैया काहे परेशान करते हो?
Then okay, so let's move on to the modulation. What is modulation and demodulation? Okay, so in our flow of communication, what we have done is our analog signal converted to digital and encode it, and then we need to transmit this information to a particular, in a channel to a long distance. So we need to have a perfect modulation scheme. So let's see what is the modulation. So the binary digits I have shown here is what is a digitized form. Or a digit-wise representation of my information signal, Rashma, I'm still hearing some of the noises. If please come, inform them that if.
Yeah, yes, sir. In between, some of them are joining. Yeah.
Yeah, I understand. Yeah.
Yeah, sir. Okay, sir.
That's okay. That's okay. I mean, just.
Yeah, yes, sir. I have muted everyone. Still, again, your mic also became muted. Could you please, sir, unmute your mic, sir?
Yes.
Yeah, sir. Really sorry, sir.
No problem.
Inconvenience.
Yeah, this can happen. This is it is more very common in the webinars. People.
Okay, thank you. Thank you for understanding, sir. Thank you. Yeah.
No problem. It's all fine.
Yeah. Okay.
Yeah. Yeah. So, okay, I think you are following, right? If something you have any question, you can anytime you can ask, because it's kind of I'm kind of doing kind of a broadcasting kind of communication right now, because I'm broadcasting my my information and you are all hearing that, but I'm not getting any response. So if you have any questions, you can chat and type in the chat, or even raise your hand or ask a question. So just for a more interactive session. So anyway, so we have the binary digits, what we generated from our analog data, from series of steps like analog digital conversion and digitization. Then we encode into digital form, like this waveform you can see here, 0, 1, 1, corresponding to this binary digit. If there is a 0, we have 0 amplitude pulse, 1 amplitude pulse, another 1 amplitude pulse. So again, we cannot transmit these waveform like this square waveforms to a channel. So that is what we use some kind of a carrier wave. As in the case of in the history of communication, we have seen the pigeon. Pigeon is the carrier. Something like that, we use a high frequency sine wave to carry this information. So how we carry this information? That's process called the modulation. So we can either show the, we need to represent zeros and ones. These are the consecutive zeros and ones. We need to convey this information. So we take this carrier and change one of the properties of that carrier wave that the receiver is able to understand what is that. So just take the first case, ASK, that's amplitude shift gain. That means you can use two different amplitude levels of the sine wave to represent 0 and 1. For example, here if you want to encode this 0, you transmit a particular lower amplitude, and for 1 you transmit a higher amplitude, again a higher amplitude, lower amplitude, higher amplitude. So essentially, this is an analog waveform which carries the digital information or the digit transformations like 0, 1, 1, 0, 1. And whenever the comes to the receiver understands, okay, receiver is able to understand. So that or the receiver is designed in such a way that it is able to understand this transition of the amplitude of the carrier wave. So immediately it will decode that data. Like the receiver, when receiver sees this amplitude, okay, it recognizes that it is a 0, and if this is higher amplitude, it is 1, something like that. So that is what is called keying, shift keying, amplitude shift keying. We change some of the properties of the carrier. Similarly, here you can change the frequency. You can use two different frequency of this carrier sine wave to represent that it changes. That 0, 1 frequency and 1 for another frequency. So it is a kind of indication to the receiver that when this particular frequency comes, that is this 0, and this particular frequency comes, this is 1. In that way, you can decode your binary data. Something like you can use phase of two different phase for zeros and ones. So once the receiver sees this, receiver is able to recover the data what is embedded on that carrier wave. So this is a very simple form of modulation and demodulation. This is in general we call this as digital modulation schemes, because we are modulating an analog carrier with the digital information. You can modulate analog carrier with analog information too, but in most of the modern communication system, we digitize the signal first and transmit the digital signal. That's why it is digital communication. This is very basic of digital communication system. We need to transmit our digitized information by instantaneously varying the characteristics of your carrier wave. Okay, so that is simply modulation. And at the receiver side, the receiver will do the demodulation. So let's move on to the multiplexing and demultiplexing. So we have seen what is analog to digital conversion. That's first step in our communication. Whatever we generate is in analog form. We convert that into digitized form. So digitized form is easy to process, and we encode our waveform into particular codes or particular digitized waveforms. Then we embed that digitized waveforms or digits onto the high frequency carrier. That is called the modulation process. Something like we write the information on the letter, and that is what is analog to digital conversion and encoding, the message generation. Then that paper is tied to the pigeon's pigeon's leg. The pigeon is what is called the carrier, as we have seen in the history of communication. So that process is the modulation. We embed our digitized information onto the carrier, then transmit. So assume the case where we need to transmit many user data or many users or many transmitters transmitting many signals onto the channel, but you have only limited channel. So with the limited resource, you need to accommodate many users at the same time. How we can do that? So that elegant process is called a multiplexing, and at the receiver side we do the demultiplexing. So let's see what is multiplexing. So assume that instead of one sender and one receiver, as for up to now we have seen only one transmitter, one sender, one receiver. Now we have multiple senders, like n number of senders. 10 people are talking at the same time, but we have only one medium. So what will we do in such a case if we wanted to accommodate all these n number of senders at the same time? So that process is called multiplexing. We somehow combine or multiplex all this user information all together and transmit through the medium as a combined signal waveform. As the receiver, we do the demultiplexing to direct that particular signal, the information to the intended receiver. So we have a shared medium. So shared medium can be a wireless channel, a coaxial cable, it can be an optical fiber. So anything can be a channel. So within the given channel capacity, we have to accommodate more number of users. So that process is called a multiplexing. And at the receiver, the opposite term is demultiplexing. That is the decimate the received information to your different receivers. So there are different possibilities we have for this kind of multiplexing. The most common and the most popular technique is a time division multiplexing. We will see what is the time division multiplexing. Then frequency division multiplexing, and also another term somewhat analogous to the frequency division multiplexing is wavelength division multiplexing. So these are the techniques, well studied and well developed techniques for multiplexing or accommodating many user data at the same time in the same given channel. So let's move on to what is time division multiplexing. So assume that we have many users. Just an example. Assume that we have 3 different users. Let's say S1, S2, S3, and the 3 receivers corresponding to each transmitter, R1, R2, R3. And we have the transmission channel. The transmission channel, it can be anything, wireless channel or fiber or coaxial cable. So what we do is we kind of switch the channel between the different sources. For a particular instant of time, we take the information from S1, and the next instant of time we take the information from S2, and so on. And at the receiver, at that particular time when we select the S1, the receiver switch to the particular receiver. So something like we kind of a time sharing system. For example, if there are 10 people who wants to talk in a presentation, if all of you talk all together, it will be kind of messy, kind of a lot of interferences. No one can understand anything. For example, right now I'm taking a presentation, and some of the people in between by mistake, or whenever they join, you can hear some kind of noises. That means they are also talking simultaneously as me. But for example, assume the case for for example, Reshma gives me a time for my presentation, and after that another time slot for your questions and answers and those kind of things. That's kind of a sharing the resources or the time between different users. So in that way, we can establish an efficient communication system by utilizing the existing channel, existing resource. We can accommodate many users. This is one of the prominent technology in the modern mobile communication system. We are all, whenever we are talking over the phone, it doesn't mean that you are talking continuously to your friend or your receiver. You are actually kind of a time sharing the channel. Many users are also time sharing. You are given a particular time slot, but you are not experiencing that. That is how the communication system algorithms efficiently do all this kind of scheduling, synchronization, a lot of things behind that. It's not very easy to share the channel in time. You have to perfectly synchronize the transmitter and receiver. Otherwise, the user, otherwise the sender one's message will go to receiver 3. That is not intended. So there should be perfect synchronization between all these. That is the technicalities behind this implementation of the techniques. But anyway, I'm just trying to introduce what is time division multiplexing. We share the channel with dividing the time slot for the different users. Similarly, we can do the same thing. So one important thing I wanted to let you know here is this. I just want to coin a very important technical word everywhere we use in communication system is the orthogonality. Maybe some of you have heard this word before. Orthogonality means in technical, there is no interference between any of the users. For example, you can see here the red block, this number 4 is a message from sender 1, and this blue block is coming from S3. So, and there is a gap in between, there's a white space in between 4, 3, 3, 3, etc. So that is what it means that these are all orthogonal. That means there is no interference between, there is no connection, or there is no merging between these message blocks or the time slots. So it is, technically speaking, it assumes that it is orthogonal. That means no interaction between all these blocks. That is called the orthogonality. So, but in reality, it is not the case because the channel is noisy, channel is, time dispersive channel, or multi-path channel. Channel can have many different problems. So it will lead to some kind of interference. So there are algorithms, designed at the receiver side to mitigate those issues of interference. So, but in general, when you speak in a general point of view, in technical point of view, all these message time slots are orthogonal. So please keep this word in your mind, orthogonality. That means there is no interference. Similarly, we can multiplex or over the frequency domain. That means different frequencies, like let's say A, B, C, and D are the different frequencies allocated for different users. That means you can transmit your encoded analog waveform in that particular carrier frequency. There are 4 different carrier frequencies, and you can multiplex together and transmit over the channel. So that is multiplexing over frequency. And analogous to that, there is another, maybe in literature you can see this wavelength division multiplexing. That is very similar to frequency division multiplexing. This is also separated in frequency, and there's a perfect frequency band between these different users or different senders. Then there is, again, these are orthogonal. But the wavelength division multiplexing basically used in optical domain. If we use optical carriers or high frequency optical signals or lasers for the communication over optical fiber. So this, why we choose the wavelength instead of frequency means wavelength is corresponding to different color, So the different color LEDs, sorry, not LED, the lasers for the optical fiber. Different color lasers can be used as a carrier to modulate your digitized information and transmit over the fiber without any interference, in generally speaking. So the frequency division multiplexing and wavelength division multiplexing and analogous similar concept, but both of them are used in different scenarios. In the radio frequency sense, in the wireless communication, frequency division multiplexing (FDM) or FDMA is the more popular, and in optical fiber kind of communication where we use high frequency signals, we are characterizing with wavelength instead of frequency. That's called wavelength division multiplexing. So A, B, C, and D are having different wavelengths. We encode our data on different user data, user A, user B, user C, and user D, and multiplex all together and transmit through the same channel and demultiplex at the receiver. So all these techniques are, we are assuming that these are orthogonal. There is no interference. Okay, let's come to the multiple access. So this is some kind of technique. It is very vastly studied, and still a lot of researches are going on, in the communication system to improve the capacity, its reliability, data rate, all these things. Let's see in the last block is the last block in the transmitter, but first block at the receiver, the multiple access. Okay, so before moving on to multiple access, I just want to explain this multiple access in the wireless communication scenario. This is mostly, in the mobile communication, we use wireless channel basically for the access side. Access side in the sense communicating with the end device of the receiver. So, so let's see what is happening here. So we have a mobile here, a mobile receiver, and for example, we are trying to communicate with this mobile receiver. What we do is at the transmitter, we do all this transmission, several blocks, and we finally end up the signal in an antenna. So antenna will propagate or broadcast the signal. So this circle shows how the electromagnetic signals are radiating over the space. And once we radiate these electromagnetic radiations, these are the modulated our transmission signals. So, and this antenna is called the base station. So in the communication, sorry, the wireless communication scenario, what is happening is that our mobile communicate with the base station to recover the receive the information. So here the base station transmits several, modulated electromagnetic waves carrying our information, something like a pigeon carrying the return message. It will come through the receiver or the mobile through different paths, because it is broadcasting. It's an electromagnetic wave. It can take any path to the receiver. That is called a multipath. So it can take multiple paths to the receiver. You can see there is a direct path, but the problem here is in the direct path, this arrow, this red arrow, there is an obstacle in between. There is a tree. So essentially, a tree will cause some kind of distraction to this line of sight signal. This is called a line of sight. That is a direct short distance path of the signal to this mobile. So there is an obstacle. This is called a scattering or shadowing. You can see this kind of keywords in the technical publications. So it will cause some kind of a path loss. And again, it will go to some other direction and it will reflect from this building, very high building. So the signal electromagnetic wave may reflect, take a different path and comes here. So you can see that essentially the transmission distance for overall, all these transmission arrows are different. This is a direct path, much shorter distance, but obstacle here. It will go through here, causes some diffraction and the spreading of the light, electromagnetic wave, and reaches the receiver. So it will take different paths to the receiver. That is called a multipath. So that causes some kind of problem, time delay between same data, same message will come to the receiver at a different time instant. So that will cause some kind of interference. So this is a generic wireless communication scenario. This is the signal coming from base station to mobile is called a downlink. That is called downlink communication. And if this mobile sending information from mobile to the base station is called an uplink. So we have two different scenarios. Here we only talk about the downlink, that is base station antenna to the mobile station or mobile unit. So another thing also I just wanted to point out here is we have only one base station antenna and one antenna for the mobile unit, right? So that is called a single input, single output. So these are all different areas, research areas of communication system. I just want to make it very simply to let you know what are the different keywords, like so this is called a single input, single output. That means only single antenna and single output antenna, single input, single output. But still there are a lot of issues because single antenna just radiate its electromagnetic wave in all the directions uniformly. It's kind of an isotropic antenna or something technically. So this is causing this kind of problem. There are algorithms there to kind of maximum ratio compressor, maximum ratio, some kind of equalizers are used so we can recover the signal still, but this is a general scenario of a wireless communication system. Okay, so our motivation to talk about what is multiple access. So this is a place where we need to use multiple access techniques to improve the throughput of our means, reliable transmission of our data to the receiver. So, okay, let's talk about the MIMO. So I'm not sure I'm dumping all these technical things on your top of the head, but just hear this and some point of time you may realize, okay, you can go to Google and search what is MIMO, you will get much more information. But I just wanted to coin these terms. These are the techniques currently used in the communication. So this is a single input, single output. Okay, so people think about why can't we use a multiple input, multiple output, like multiple antennas to transmit and multiple antennas for the reception. You have several advantages by doing that. For example, assume that your base station is equipped with the multiple antennas. See, this is M antenna base station. This base station has several antennas together, and you have different users, user 1, user 2, and user n. We have to accommodate all these users And this user 1 is intended to communicate with this user 1 receiver mobile phone, user 2 to user 2, and so on. So we have n number of users and n number of receivers. So if the channel, if our base station antenna is equipped with multiple antenna, what is possible is we can do some kind of a space division multiplexing. This is what I wanted to go in here: space division multiple access, SDMA. So in MIMO systems, MIMO means multiple input, multiple output. That means multiple transmitter antenna and multiple receiver antennas. But this particular case, we have only one receiver antenna just for the illustration purpose. In some of the advanced communication system, you have multiple antennas for the receiver too. So that's a different scenario. Anyway, so what is happening here is, okay, this user 1 data comes here. We will talk about what is pre-coding data. So this is a block called pre-coding, and this CSI is called a channel state information. That means we should know about what is going on in the channel, what kind of a channel it is, or what is the characteristics of a channel. Once we know that, it is easy for us to design algorithms or alter our data in such a way that it can be well suited or well transmitted through the channel reliably, more reliably. So that is what called as channel state information. So these are things, the technical things we can see in any of the research papers talking about MIMO systems or wireless communication. You can search in the Google. You can see a lot of papers talking about that technically. So I'm not going into deep. So okay, so we have multiple antennas. So once you have multiple antennas, you can do some kind of a process called a beam forming. And please note this keyword to beam forming. So beam forming is a kind of generating a particular antenna beam. We can make it more directional towards a particular receiver. Here, in this case, we have only one antenna. This one antenna only can radiate, uniformly in the space. So that's a uniformly distributed electromagnetic wave all over the space. So if you have many of such antennas, and if you apply some kind of a process called beam forming, that is what is happening here. In the pre-coding, we do some kind of coding which is essential for beam forming. That means we make this antenna much more directional to this user. So the user one, this the red arrow and this red beam form, the user one can communicate with this user receiver one through this particular beam. This is an electromagnetic radiation. So these are all shows electromagnetic radiation, something like here. Here is a broadcasting. Like it will go to, for example, if you have another user here, this signal will come here. So this is not the case. Here we kind of do a process called a beam forming, and we create some beams, electromagnetic beams, in which users can directly connect to the receiver. So this red one for this user one, and this one for this one, this blue one for another user, and the green one for the end user. So this is called a spatial multiplexing or multiple access. We divide this space into different beams. With these different beams points through, is a beam or is a wave vector is something like that. It is generated beam which doesn't have interference with other beams. So without interference, essentially you can accommodate many users with the many antennas and beam forming. So just wanted to, this is a very big research area. It's not that easy to generate beam forming. If beam forming is not properly done, what will happen is that you will end up with the interference between all this. So interference causes noise, and you cannot recover actual data intended for each user. So what we are doing here is, in the spatial domain also, we multiplex. That means multiple users can use a particular portion of the space even with a technology called a beam forming. So for beam forming to realize, we need to have multiple radiating antennas. So that is what is called the MIMO with the space division multiple access. So this is a very well developed area, or still researches are going on. Mostly this is one of the big player in 5G networks. You may be seeing, what is 4G, 5G. Maybe in India still 4G is what we are, the 4G services are only available. The 5G systems, the system should be upgraded to this kind of technologies. So multiple input, multiple output, space division, multiple access, or MIMO with SDMI is one of the key enabler for the 5G technology. That means we divide the space even. That is called space division, multiple access, because we are talking about multiple access technology. Okay, so let's going to the next one. I just want to point out another technique, another key technique coined in the 5G. Still, it is in the implementation stage. It's not fully implemented, this kind of techniques. That is called a NOMA, non-orthogonal multiple access. So I think I mentioned you should keep in your mind when we're talking about this multiplexing, all these messages are orthogonal. That means there is no interaction between these information blocks. Those are orthogonal or orthogonality. So, for example, if many of such users comes in, we have the limited channel and limited time resources for multiplexing. What we'll do? We should adopt some other techniques which are, other than this orthogonality. If you break the orthogonality, we can accommodate much more usage. That means, spacing this 4 and 3 much closer, or even interfering. For example, if you interfere 4 and 3 and place it very close, you can accommodate many users, but you have an interference. And for example, this interference is a control interference. And if you are able to recover, or if you are able to remove that interference, okay, still you can have an efficient or reliable communication. If you are able to recover your data, even if you have an interference. So if interference happening in the channel, it is very difficult to recover. But if we intentionally apply some kind of interference by closely packing all these information blocks, we might be able to recover that, because we impose that kind of interference. So such systems are called non-orthogonal multiple access systems. In single word, it is NOMA. It's a very well-known research area going on in the wireless communication. If some of you are attending this presentation on wireless communication, you may be knowing what is the research potential of these NOMA systems, non-orthogonal multiple access systems. So that is another a big technical advancement from the 4G to the 5G. So when we talk about these multiple access techniques, this NOMA, non-orthogonal multiple access, see this graph here. In the x-axis, we have a time or frequency. You can have a time division multiplexing or frequency division multiplexing, whatever it is. So that is actually orthogonal multiplexing technologies, time and frequency division multiplexing. I mean, different time slot for different user without overlapping, or different frequency for different usage. So here in the x-axis, we have that time or frequency resource, and in the y-axis, I have the power. So this is the one of the technique. Like we can even multiplex over the power. So assume that there are two users, user 1 and user 2, and this orange color shows that okay, I am assigning some amount of power to the user 1 and much higher power to the user 2. So in the power domain itself, we can multiplex more usage, use more data, but we have interference. Why? Because we are in the one of the time or frequency slot assigned to a particular user. For example, we assign a particular, we have a particular time slot in which in the orthogonal multiplexing system, we use that only for particular user. But in the NOMA system, what we do is in that particular block, we assign two users instead of one user. If you assign only one user with a particular power, that is orthogonal multiplexing. And if you accommodate two users with two different power in the same time slot or frequency band, that is called a non-orthogonal. That means there is a controllable interference between user 1 and user 2. But these two are in different power level. So this is called a power domain NOMA, power domain non-orthogonal multiple access. So how we can recover this? What is going on in this case? So when this base station transmits an information like user 1 and user 2, and this green color mobile receiver is intended for user 2, and the orange color is for user 1. So what is our ultimate aim is you need to recover data for this user 1 and user 2 efficiently. But what we are doing here is we transmit user 1 and user 2 with 2 different power levels in the same time slot or frequency. So what is going on here? So since you have higher power for the user 2, in theory, if you have developed a particular algorithm software, it is able to recover user 2's signal, because high power means you have more quality data, right? So user 2 is at high power. You transmit user 2 information at high power, and this mobile is able to recover user 2 data without much interference from user 1, because user 1 power is low and user 2's power is high. So the interference from the user 1 on the user 2 is much less because of the low power transmission. So this user 2 can efficiently recover or decode data for user 2, since it is a strong user. This is called a strong user. This is called weak user. The strong user decode data. Then what is happening here? Once you decode the strong user data, the signal comes here involves both user 1 and user 2 data, right, for this mobile. Once you decode the user data, you subtract that from the signal here. What you end up with the user 1 data. So it is something like, with the help of a strong user, you decode the data of strong user and subtract from the combined signal. So what I'm saying here, this base station transmit combined signal to here. That means because we transmit user 1 and user 2 data at the same time or same frequency. So user 1 plus user 2 here, user 1 plus user 2. Here user 2 decode the user 2 data, and from here what this user 1 is receiving is user 1 plus user 2, and we have user 1 plus user 2 minus user 2 becomes user 1. So that is what is happening. So with the help of this decoded data of a strong user, we were able to recover data from the weak user. So this is called a non-orthogonal multiple access, and what SIC is called a successive interference cancellation. So this is a well-designed algorithm used to subtract this user 2 data from the combined signal. That means there's a kind of interference mitigation that is called a successive interference canceller. So the successive interference canceller is cancelling the decoded user 2 data from user 1. So end up with the user 1 data and user 2 data separately. So it's very easy to explain and very easy from the explanation point of view, but technical point of view, this is not that easy. So you should have sophisticated techniques and technologies to realize this kind of a system with a controllable interference. There are several pre-coding techniques available in the literature. If you go and type in the Google NOMA, non-orthogonal multiple access in 5G, so this is, you can see a plethora of papers or bundle of research projects already in place in world-leading universities. So this is what is NOMA, non-orthogonal multiple access. So we have talked about what is orthogonal multiple access by sharing the channel between time, frequency, or wavelength. Or in that cases, all are orthogonal, no interference, not much interference. But this is a case where we add a controllable interference to accommodate more users, to increase the capacity throughput, and we develop techniques or algorithms like a successive interference canceller for recovering the data efficiently and reliably. So just note this name, this term, NOMA, non-orthogonal multiple access, and this is a power domain NOMA. There are different other techniques that are also available, core domain NOMA, something like SCM, space code multiple access. That's a different NOMA technique. I mean, I'm not going to talk about that, but this is a very well-known and mostly researched area, like the power domain non-orthogonal multiple access. So very kind of a latest. I think most of the thrust started in 2018 and onwards. Researches on these NOMA systems are going on.
Sir,
okay.
Sir?
Yeah. Sure.
Yes, sir.
Someone
Actually,
yeah.
Yes, sir. We are like keeping those data together since we can send more data at a given time, no, sir.
Sorry, I can't hear you well. Can you please repeat the question, please?
Sir, can you hear me?
Yeah. Yeah, I can hear you now. Yeah.
We are sending data closely so that we can send more data in the given time, no, sir.
Yeah, exactly.
But while decoding data, it will take time, no, sir. So what is the use? Like,
Yeah, I mean,
there it is taking extra
yeah.
time.
Yeah, that's a very brilliant question. Yeah, definitely. So it might be cause some kind of latency in decoding, especially user one's data, because you need to decode the user two data first. But we cannot say that this. I mean, so this latency or delays are in the sub-milliseconds time scale. That is not that. Yeah, that is one of the objective in optimizing this kind of techniques. For example, this successive interference cancellation algorithm. All this should be done in a much more. I mean, the running time of the algorithm. So everything should be kind of optimized well. So definitely there is a time gap or time delay between the decoding of user one and user two. But on top of that, the advantage of accommodating many users is more prevalent than that minute delay. So that is what is research is going on. You should be able to recover data, user data first, and subsequent interference cancellation in a sub-millisecond time scale. That is what is research. So this technique was more researched in 2018 and onwards. Now these kind of latency studies or researchers are going on still to reduce the latency. Definitely, that's a very good question. Yeah, that is one of the drawback you can say.
And
but
also, sir, what is actually yes, sir. Yes, sir.
Yeah, go ahead. Yeah, go ahead.
Yes, sir. What is actually that beam, sir? Or like, can you explain it? Like, what beam is
This
that?
one, right? Okay,
Yes,
this is
sir.
electromagnetic radiation. That's it. The beam means electromagnetic radiation itself. So what is happening here is, if you have one antenna, and then when antenna transmits, is kind of isotropically, it will propagate in all the directions, right? It's something like this. The circle shows. So here, what is happening is that if you have such antennas multiple, what is happening is that you will be having some kind of successive and destructive interferences. So that is called the beamforming. So beamforming is a technology or technique used to steer your antenna beam to a particular direction. It's because of because you have multiple antennas, all are radiating, and this radiation pattern will interfere constructively and destructively. So, but in a controlled way. So that is what is called beamforming. So beamforming is a technology to control your destructive or constructive interference between these multiple antennas, and you can generate a wave or a wave directed towards that. So this is what is still it's an electromagnetic radiation, kind of a more directed antenna.
Yes.
Yeah, it's nothing more than that. It's just radiation, but the radiations are orthogonal to each other. That beams. Yeah, it's not very easy. Yeah. The beamforming is a very complex technique. It's a lot of things behind that. It's a big algorithm to do that. Yeah, so these are the enablers in 5G, and still researches are going on. I mean, your question is really a good question, like the latency in decoding. So that is one of the motive in researchers to reduce that, that decoding time if you have multiple users. So this is still only one user one and user two. Assume that you have multiple users. This is a scenario where something like maybe your question may automatically goes to this scenario where you have multiple users, you have more delays. So to avoid such kind of decoding delay, one of the technique is a cluster based node. I mean, because we utilize the advantage of MIMO, like MIMO in the sense the space division multiplexes with the different beam forming, along with the NOMA, that is called a MIMO NOMA. So this is another possible technique where you may be able to reduce the decoding time. For example, if you have I'm just going back to that question again. I think Bala's question. Assume that we have multiple users, 4 or 5 or 6. What is happening? And we need to identify the strong user first, decode the strong user data, and successively you need to you do the successive interference cancellation for decode each of the user data. So it will take long time, right? In that case. So this is part of your question. So this is another one possible way to reduce that time delay in decoding. For example, you have multiple, here there are 4 users, 1, 2, 3, 4. And this is one of the technique. We cluster that into 2 different clusters. So since your multiple antenna, okay, if you replace this base station antenna with a multiple antenna, you are able to generate the beam, right? Or beam forming is possible. So with that beam forming, or the users coming in the vicinity of that beam, we take it as one cluster. That is called a clustering technique. We have cluster 1 and cluster 2, each cluster with 2 users, something like this scenario, 2 users in one cluster. So essentially what is happening is we can decode all these, at least the user 1, user 2, user 3 and 4 at the same time, because we are utilizing the space division multiplexing technology with the beam forming. That is what is MIMO. So here we have this beam, and this U12 and U11 comes in the vicinity of this beam and this beam. Okay, so we can do same thing because these are spatially separated. So you can do this process without any interference between the cluster. I mean, technically speaking, but there will be interference in the cluster. There are other techniques we need to do some kind of pre-coding to avoid that. But anyway, what is happening here? In the assume that okay, S11, S12, S21, S22. This 1, 2, the first letter belongs to the cluster. Okay, S11 means this data to user 1 in the cluster 1. S12 is data to user 2 in cluster 1. Similarly, S21 is data to user 1 in the cluster 2 and user 2 in the cluster 2. So what is happening in the MIMO system will generate a particular beam forming, like this beam forming, this is here. We have cluster 1, cluster 2, user 1 and 2 here. What is happening? Okay, let's assume that this particular case, the user 1 is the strong user in each cluster, and user 2 is the weak user. In any case, you can have, okay, maybe user 2 can be strong, user 1. It depends upon how you assign the power to these users, okay, in power domain normal. So what is happening is here, since user 1 is strong in this cluster, it will decode first, then do the successive interference cancellation and decode data for user 2. Similarly, that is same thing happening here. You decode second user 2 data, then subtract from this, and you recover the user 1. So these 2 things can be done simultaneously to avoid the delay in decoding. How? That is called a clustering. So this is one of the answers to your question in the previous slide. How we deal with this, delay in doing all this decoding. But delay inside the intra-cluster delay is again a research topic. People maybe come up with new ideas, new algorithms, which are their time complexities are lower, or how efficiently, how fast you can decode users in each cluster, intra-cluster delay. So I think I have seen some of the recent papers in 2021 in Journal of Selected Areas in Communications. Some people introduce, micro cells kind of. Again, multiple antennas used in the each beam to have separate as much smaller beam forming techniques, like using multiple antennas at the receiver side also. It's very complex. It's not very easy to work on the signal processing behind that. Is not that easy, but still possible. Instead of having 2 clusters, essentially the transmitter will look like each user is a separate entity, something like a separate beams. When further you are utilizing this spatial multiplexing in intra-cluster 2, something like those things. So, but it makes your algorithm much complex to process. You might need some, the sophisticated algorithms, and to develop new techniques too. So this is what is the research going on. It's still a open research area. This MIMO, multiple input, multiple output system, utilizing the space division multiplexers. Anyway, so that is something we talk about, the basic communication system and multiplexers. I think our time is almost there. So I just want to just a small glimpse on what will be the 6G, what is after 5G, what is beyond 5G. So I just want to point out two things. Just one possible enabler in the 6G wireless communication might be, you may be heard about this, intelligent reflecting surfaces, IRS. So that is a very, very latest, very hot topic, hot research area is going on. Something like you have seen here in this wireless channel, we have an obstacle here, right? this tree is an obstacle for this direct line of sight path. So this particular intelligent reflecting system is actually, we are kind of tuned the channel itself. So what the technologies we do here, I mean, from going from here to multiplexers, what we are doing here is we tune our transmitter or receiver to cope with the channel conditions, right? We cannot do anything in the channel. Channel is there, but we are trying to develop some algorithms, techniques, multiplexing, everything at the transmitter or receiver to make your communication more reliable. That is, what is this MIMO, NOMA, MIMO, NOMA, etc. But in the next generation, the next step in the 6G, what is proposed is kind of using some kind of a passive reflectors called intelligent reflecting surfaces. So this is, very simple principle. For example, this is a base station enabled with the MIMO, that is a multiple antennas, and you have multiple receivers here, a mobile user, unarmed aerial vehicles, a smart vehicle, whatever the receiver side. You assume that if there's a line of sight path, it will be distracted by this tree in between. So what is proposed is very simple. Like if you have something like intelligent reflecting surface, that means your uplink signal will go here, it will reflected here. Something like, this can be mounted anywhere, even in the buildings, even in the trees or buildings or everywhere you can install this kind of very low cost reflectors. It should have some kind of characteristics, but what it is doing is it reflect what is coming here, and it will some kind of emulate a direct path between the transmitter and the receiver. So intelligent reflecting surface as the principle is very simple, but what we are doing is we actually tune the channel itself for a secure communication. Along with all our design techniques for the transmitter and receiver, we tune the channel itself. That's a very new approach. We cannot do anything with the channel really, but with this kind of a very simple introduction of this IRS, intelligent reflecting surface, you can even tune the channel in favorable of you for a regular reliable communication. I mean, I just want to coin these words here. There are a lot of papers available in the literature. If you are interested, you can have a look. Very interesting, very, very interesting. And all behind all this, there are mathematical modeling. So everything wireless communication, if you look into the papers, especially transactions on wireless communications or Journal of Selected Areas in Communication, everything backed up with a lot of mathematics. So whatever I talk here, like all these NOMA, MIMO, NOMA, and this kind of IRS system, everything is backed up with a lot of mathematics. It's a well-developed area. So if you are interested in that kind of research or studies, please go through that, that kind of mathematical, modeling or mathematical backup on these technologies. Okay, so the 6G, just giving us some few glimpse on what will be the 6G. 6G is still researches are going on. Still, many of the researchers worldwide are working on this. So, in a simple sense, it is a ubiquitous connection with all the techniques all together. I'm not going to each and every block here. So this is how somehow the proposed structure of a 6G network. It is a combination of all the kind of possible communication technologies, like free space optics communication. That means the optical laser beam itself is used in the free space for a line of sight communication. VLC, visible light communication, like the LED lights are all over in our home, in our office, everywhere. So instead of along with that illumination, we can transmit wireless data through that visible lights. So that is called visible light communication, and a lot of things, blah blah blah. University campus. It's a very messy figure. I'm not going to each and every topic, but whatever it is, the 6G seems like it will, enable the ubiquitous or seamless connectivity between all this. For example, you travel from one point to another, you can connect to any network. It's called a ubiquitous communication, ubiquitous connectivity. So 6G is aiming at that, any connection. Combining this space, land, air, water, all this form of communication all together in a simple, interoperable with the application of artificial intelligence, AI, and machine learning. So that's the reason why many people are working on the machine learning applications in communications. So that's it. I don't want to, blast your head with all these putting all these things in your head. Anyway, this is just a glimpse on what is going on. So this must be how 6G looks like. Still, it is in the research phase, not yet deployed anywhere. So there are a lot of research opportunities in these areas, like right from here. These things are all comes in the 6G also. Mymonoma, this mymonoma, IRS, intelligent reflecting surfaces. So ultimate aim of a communication is to reliably communicate and deliver your message in a very reliable way with the low latency. And so just one last thing I just want to point out in 6G systems mostly concentrating on healthcare technology, the more efficient healthcare system with for example, the doctors can do a remote surgery from UK for a patient in India, remote surgery. How all this can happen? So kind of ubiquitous connection, network reliability, low latency. That means a reduced time for decoding data, as Balas asked the question. How, so these are the researches going on. Hopefully 6G will be also in place in maybe in another couple of years. Who knows? Anyway, so these are my talks. This is just an introduction from basic to some advanced techniques in 6G. So you can ask any questions if I'm able to. I mean, if I know, I will definitely answer. Otherwise, I can use some references if you want. So thank you so much for your kind attention. I hope no one is slept. And thank you for Reshma and other coordinators for this opportunity. I hope you get something from this. And if you want to talk to me offline also, I'm okay. I mean, I think Reshma can share my email ID or whatever. So we can also continue the discussion if some of you interested further in this kind of communication techniques. Okay, thank you so much. I'm handing over to Reshma. Yes.
Yeah, thank you, sir. Thank you so much for Dr. Sunesh Kumar sir for enlightening the webinar by delivering a wonderful talk on the principles of communication systems. Now the participants can ask questions. If you have any doubts, you can ask now. So participants, please.
Sir, how can you apply, as the generation of communication improves, it is getting more and more complex. So application of them will be becoming more complex.
Exactly. Yeah, that is what. Yeah, exactly. Your question is correct. So ask what have you ever think about the reason why we need to go from 5G to 6G to, for example, 3G to 4G to 5G? So basically speaking, no one is happy to do this kind of things. Like, I mean, going from the here and next generation and applying complex techniques. The reason is this is because of the requirement, the user requirement. Because, for example, are you happy with the 3G connection? If you have 3G internet connection, are you happy with that? No, of course, we are not happy. We should need higher data speed, and our requirements are also high. We need to, stream multi or gigabit amount of data within seconds. We need to watch the high definition, ultra HD movies. So the requirement of data capacity, number of users using the technology are growing day by day, even minute by minute, even second by second. So how we can accommodate that? We need to accommodate all these users with some amount of user fairness or some amount of capacity achieving. So we are forced to move from each generation to the next generation. But complexity is a big problem. That is what research people do. We need to provide some efficient. So for each generation, there will be some kind of a threshold or some kind of reference points or reference milestones. So these technologies must meet those kind of, in terms of reliability, in terms of latency, in terms of complexity. So these are the researches going on. We need to reduce the complexity. So just an example, my research area, my PhD work, when I was doing my PhD in Memorial University in Canada, my work was mainly working on the optical fiber communication. So I didn't talk anything about the optical fiber, even though that is my research area, but I didn't include that here because we need a separate talk for that, talk about optical fibers. So optical fibers are the backbone. So all these network, all these systems are can be deployed only with the help of this backbone optical fiber. So my area was for, like compensating some of the nonlinear issues with a low complexity. So just point out that low complexity algorithms. So when you check my my thesis, you can see I propose 4 different DSP techniques with a low complex compared to the existing. So this low complexity implementations is a big area of research, So as you said, as Bala asked, when we put a lot of technologies into the, into the, this communication paradigm. So what is happening? Complexity. So we have to reduce somehow. There should be some, algorithm or low complex methods, techniques. So that is a never solved problem. Is still there. Even when we started from 2G, 3G, this complexity problem was there. People efficiently tackled those issues on those generations. So definitely in 5G and 6G, this is what the engineers and scientists are for. They will do some kind of techniques. People like us or people like you should think about that. How we can efficiently do these things with a low complex. So that question is really a good question, and it's still a standalone question to any researcher, how we can do very efficiently with low complexity. So that is the answer is still researchers are going on. We cannot say that this one particular technique to reduce complexity. It's a combination of many approaches. I think I answered your question, but I'm not sure I answer well or not. Maybe maybe it is satisfying to you. Okay, thanks for your nice question. Yeah, this is a very great question. Yeah. So anything else?
Thank you, sir. Is there anyone else? Is there anyone else to ask question?
I do have a question. Thank you for the excellent presentation, Dr. Sunish Kumar. It was covering like from the basics and all the way up to 6G. Very nice talk. And my question is that given the chance, like you had your education in India and abroad, as well as you have experience as a faculty in India and abroad, being this conference is organized for motivating the students towards undertaking projects, in the Indian time scale of their graduation, what kind of projects you can suddenly think of suggesting for the students which can be done at their education time scales?
You mean for the example, the undergraduate students,
yes,
in a limited time
space,
right?
Yes.
Yeah. It depends on, I mean, this is also a very good question, like what to say, standalone question anyway. So the selection of the research topics or anything depends on, okay, I must say some another thing. For example, to any engineer, even if it is a electronics engineer or even in the basic scientist, you are all end up with a limited time frame, right? You will not given an infinite time period to do whatever you want to do. There is no point in doing that. For example, if you take a big thing, okay, I'm going to prove that the relativity theory is wrong. Okay, if you take your lifelong time to prove that it doesn't, okay, that you should do something beneficial to the society, community. So when it comes to this question, the answer is it depends on your resources. I won't say your intellectual resource is what you have. Everyone can develop. That depends on your training, your experience. It will develop intellectual resources. Depends on the other resources what you have in hand. Selecting this topic of research is a big task. That's the first thing towards a successful completion of a project. If you select a particular project right way, almost 60 to 80% done. Like in the given time frame is not only the problem. Your available limited resource is main important. If you are very highly bright, or I won't say this bright, but because everyone is bright. So if you can develop, for example, you are given with all these systems, is just a day to integrate all these things and get your result. It will be done in that time frame. But if the resources are not available, you end up with nothing. Even if you spend much long time. So to answer your question, first of all, think about what resources we have and what solution we can solution we can provide in a limited time frame. It can be anything, even a small. For example, Bala asked a question: the complexity. if you can end up with an algorithm which may reduce 1 millisecond of time of computation, that's a big advantage, big thing. You know? So I don't know how to say to a communication engineer. I would say in a this kind of research, like this kind of project for undergrad studies, try to for example, you are given with 3 months of time. Mostly, I would say, in my suggestion, you should take that time to thoroughly understand a particular area of, for example, take the VLC. You understand first, thoroughly understand first. Don't try to. I mean, my process always said, don't jump into the research. You know, don't jump into the ocean without any life jacket. You know. So your life jacket is your information, knowledge you gain. Then you jump. You have the time to jump. So first of all, understand the basics. Yeah.
Perfect.
I think
So,
I answered the question. I don't know. I mean, I go
yes,
here and there.
you did answer my question.
Yeah.
Given the answer, I thank SRM for organizing this fantastic conference series and arranging these talks. Just a comment to all the participants, like I hope one of the participants might have finished having Pani Puri by this time. So the SRM coordinators have had, put a lot of efforts to coordinate this event. So when the opportunity is given, the students should grab it and, elevate yourself. And there are very active participants like Bala and others who have asked the questions. Congratulations to them. Be active in participating and use the opportunities that SRM is giving to you. Thank you, Sunish Kumar. Thanks, and thanks to the coordinator as well. Bye.
Thank you, Venkatesh, for your question.
Venkatesh, thank you so much for your feedback. And so, is there anyone else you can ask the doubts now? I think, sir, there is no one to ask question. I think all fine. I think,
yeah.
sir.
Either they understand completely 100% or nothing understand. I mean, anyway, this is quite common, So it's okay. Yeah. They may guess something. I mean, if they have any questions in their mind offline, I am happy to respond to that. Maybe by email or any communication medium is fine, even social media or whatever. Yeah. Anyway, just one last sentence. Again, thank you so much. Yeah.
Thank you, sir. Thank you so much for having you as our speaker, and thank you so much once again. And thank you all participants for joining with us. Yes, sir.
Yeah, just one last thing is to my students. So I won't say students; they are the fellow researchers. Just ask questions yourself. Just one good example is the Bara's questions were excellent questions. Like everyone should have this kind of might be having this kind of questions in their mind. So just brainstorming. Ask questions, a lot of questions. This asking question is way to where one of the ways to the solution. If you doesn't ask any question, like doesn't mean that ask question to me in this presentation. I'm saying that just ask question yourself when you are studying and try to find a convincing solution for that. That is the research. Anyway, thank you so much for Reshma and other coordinators from SRM for giving me the second chance to present again. Like I think last July also we did another presentation. Yeah, this time also.
Yes, sir.
I'm very happy.
Thank you so much, sir. Thank you so much for accepting our request and delivering a wonderful talk with our students. Thank you so much, sir, once again, and thank you so much all the participants. So, sir, shall we wind up the meeting, sir?
Yeah, sure, we can wind up, and please be safe in the midst of this, pandemic. I hope everyone will be safe. So please be safe. That's the only one last thing I wanted to say. Okay.
Yeah, you too, sir. Please take care, sir.
Have a nice evening. Okay, thank you. Okay, bye bye.
Thank you, sir.
Bye.